This is the Basic Skills Review additional problems found at the end of the Basic Skills Review document. So we'll start out with some fraction concepts again. So number one, we have 2/7 plus 3/5. Since this is addition of fractions, we have to have an LCD. The LCD of 7 and 5 is 35. So I am going to write my fractions below with the LCD that I'm trying to get to. Then I say, what do you do to 7 to get to 35? It's multiply by 5. So we do that in the numerator also. What do you do to 5 to get to 35? It's times 7. So we do that in the numerator also. Now that I have a common denominator, I can combine my numerators. 10 and 21 is 31. So we end up with 31 over 35. Number two, we have 5 and 3/4 minus 2 and 11/12. So two things going on here. First, we need to change the mixed numbers to improper fractions. So 5/4 are 20 plus 3 is 23/4 minus 24 and 11 is 35 over 12. And the next thing that we need to have is a common denominator. In this case, because 4 divides evenly into 12, 12 is our common denominator. So this one is already good. This one we say, what do we do to 4 to get 12? It's times 3. So we multiply that numerator by 3 also. And I have 69/12 minus 35/12. So I know that my answer is going to be over 12. 69 minus 35 is 34. Now both of those are even numbers, so even as an improper fraction, I can simplify by dividing by the GCF, and I end up with 17 over 6. It's not necessary to change that to a mixed number. Number three, we have 8/15. Now this is multiplication times 25/12. So I do not need to have a common denominator when I multiply or divide, and since I am multiplying, I can cross cancel. So I'm looking for a number that goes into both 15 and 25. That would be 5. Goes in 3 times, it goes in 5 times. What goes into 8 and 12? That would be 4, goes in there. And now all I do is multiply across, and I end up with 2 times 5 over 3 times 3, or 10/9. Again, not necessary to change it to a mixed number. Number 4, with fractions, we have again some mixed numbers, 2 and 3/4 divided by 1 and 5/6. More than one thing going on here, but the first thing we want to do is change this to an improper fraction. So 4 times 2 is 8 and 3 is 11/4. Keep it as division initially. 6 times 1 is 6 and 5 is 11/6. And now we're going to do keep, change, flip. You don't want to try to do that all in one step. So I keep the first, change to multiplication, flip to the reciprocal of the second one. And now that I am multiplying, I can cross cancel. So 11 goes into 11 one time, 2 goes into 4 twice, into 6 3 times, and I end up with 3/2. So those are some samples problems for fractions. Next, let's look at exponent problems, starting with number 5. It says to simplify and write answers using positive exponents only. We have the monomial -4 m to the -5th n to the 12th times 5 m cubed n to the -9. So it's multiplication of two monomials, so we're going to multiply like parts. -4 times 5 is -20. M -5, M3. So it's M -5 times M cubed. Those are like bases, so we add the exponents, giving us M to the -2. And then I have n to the 12th, n to the negative 9th. Adding those gives me n to the 3rd. Now we're not finished because the directions said to leave with positive exponents only. This is the one right here, the negative 2, whose base is unhappy. So we keep negative 20, we keep n to the 3rd, but m squared goes to the denominator and becomes positive. All right, number 6, another exponent problem. We have negative 4, x to the 0, y to the negative 5 to the negative 2. I think the safest way to do this is to show that this negative 2 applies to everything inside. So it's a negative 4 being raised to the negative 2. Notice I put it in parentheses because the negative is included. X to the 0 to the negative 2. Y to the negative 5th to the negative 2. Now I'm going to do each one separately. Negative 4 to the negative 2 means the reciprocal of negative 4. So 1 over, it's still a negative 4. And we want it to be squared. This is going to be x to the 0 times negative 2 is 0. Y to the negative 5 times negative 2 is positive 10. Still not finished. Let's go ahead and square this. So it's negative 1/4 times negative 1/4 is positive 1/16. This just makes a 1, so I don't need to show that. Y to the 10th, and I can simplify that even more by saying y to the 10th over 16. That's its most simplified form. Number 7, more exponents. We have 2r cubed to the 4th, r to the negative 2, all over 2r to the 5th. Several things happening here, and you need to be very careful. In this first piece, my 4 exponent belongs to both. So it's going to be 2 to the 4th, and then r to the 12th. Inside-outside exponents, r to the negative 2. We'll deal with that in a minute. Here, it's only the r that is to the 5th. So continuing to simplify, 2 to the 4th is 16. R to the 12th times r to the negative 2. That's the product rule. So I add my exponents and get r to the 10th over 2r to the 5th. And now all I need to do is simplify. 2 goes into 2 once. It goes into 16 8 times. And to simplify this, what I do is I subtract, because it's the quotient rule, 10 minus 5. So it's 8r to the 5th. There was a lot of exponent rules going on there. I think I can fit number 8 on. I have s to the negative 3, t to the negative 5 over s to the negative 2, t to the negative 9th, all to the 4th. I'm going to simplify inside before I apply that 4. So I know that this one's unhappy, this one's unhappy, unhappy, unhappy. So they're all going to move. So what's going to end up happening is s to the negative 3 comes down here and is positive. X to the negative 2 goes up here and is positive. T to the negative 5 comes down here and is positive, and t to the negative 9 is up here and is positive. Now we can still simplify before we apply that 4. These two s's cross cancel 2 of those, leaving 1. These 5 cross cancel 5 of those, leaving 4. So what I have now is t to the 4th over s, all raised to the 4th power, which is going to be t to the 16th over s to the 4th. Now, even though this is division, they're not like bases, so I can't subtract those exponents. One is an s and one is a t. All right, let's go to the next set of problems in this section, and those are problems on polynomials. We will start with number 9, and we have negative 8x squared plus x minus 2 added to 5x cubed plus 3x squared plus 4. This is just straight addition of polynomials, which is nothing but combining like terms. So I'm going to start with the highest exponent, 5x cubed. There's not another one, so I cross it off and just write it. Here I have a negative 8x squared, positive 3x squared. That's minus 5x squared. Notice I crossed them off as I used them. Here I have an x. It has nothing to go with, so I'm just going to include it. And then negative 2 and positive 4 is positive 2. Looking at number 10, we have one that is subtraction. So it's 3p squared minus 4p plus 7 minus 5p minus 1. What you want to do with subtraction is change to addition, change all the signs that follow, including that first one. Don't forget to change the sign on the first term after the minus sign. So going in order, I'm now going to combine like terms. 3p squared has nothing to combine with. Negative 4p and negative 5p is negative 9p. And 7 and 1 is 8. So subtraction, you change the sign to addition and you change all the signs that follow. Number 11, we have a FOIL. So we have 3y minus 4 times 7y plus 1. Straight FOIL. So first, 21y squared, outside 3y, inside negative 28y, and last. Combine like terms, 21y squared minus 25y minus 4, and you have it. Number 12 is multiplication, but it's not a FOIL because there is an extra term in the second piece that I am multiplying. So I'm going to use two different colors to show you what we do. It's a double distributive property, nothing hard about it. We're going to use green and multiply first everything by 3w. So 3w times w squared, 3w cubed, 3w times negative 6w, negative 18w squared, 3w times positive 3, 9w. Now in black, I'm going to multiply and distribute this positive 2. So I have a positive 2 times a w squared. Rather than writing it here, since it's 2w squared, I'm going to put it under its like term. That makes it easy to combine. Positive 2 times negative 6w minus 12w, and positive 2 times positive 3 is positive 6. Draw the line, and now let's combine. This has nothing to combine with. A negative 18 and a positive 2 is a negative 16w squared. A positive 9 and a negative 12, see they're already lined up like terms, is a negative 3w, and then we have our positive 6. Okay, the next one I want to put a star by because this one is so frequently missed and there's really no reason to miss this. It's 8z plus 3 squared. That does not mean 8z squared and 3 squared. It means the whole thing times itself. So what you have to do is write that binomial twice, 8z plus 3, and then FOIL. So first, 64z squared, outside plus 24z, inside plus another 24z, and then last plus 9. So combining like terms, we have 64z squared plus 48z plus 9. Not hard if you remember to write it twice. Number 14 is division of a polynomial. So we have 8m to the 10th minus 6m to the 5th plus 4m cubed minus m all over, that's a plus there, negative 2m. Since we are dividing by a monomial, we're going to split this fraction into 4 pieces over the same denominator. So 8 m to the 10th over negative 2m minus 6m to the 5th over negative 2m plus, see what I'm doing? Each term in the numerator goes over that common denominator. And now we just have to deal with signs. So 2 goes into 8 4 times. This m cross cancels one of those, but I have a positive divided by a negative is a negative. So I have negative 4m to the 9th as my first term. Next, a negative divided by a negative is a positive, so I'm going to write that first. 2 goes into 2 once, it goes into 6 3 times. M cross cancels one of those, so I have positive 3m to the 4th. A positive divided by a negative is a negative. 2 goes in 2 times. This m cross cancels one of those, and I have minus 2m squared. And a negative divided by a negative is a positive. M cross cancels m. Be very, very careful here. What's left is a 2, but look where it is. It's in the denominator. So I have to put a 1 there remaining in the numerator. Don't just write plus 2. That's not the same thing. This next section is on factoring. And there's one of each of the kinds of factoring that we talk about. So starting with number 15, I have 12x squared plus 48x squared y minus 30y squared. It is a trinomial, but because it has some common factors, I'm going to factor out a GCF. So you want to look for that GCF. So what goes into 12, 48, and 30? I believe it is 6. So I'm going to factor out a 6. This one has an x squared and this one does, but this one doesn't, so I can't factor out an x. These two have y's, but this one doesn't, so I can't factor out a y. So let's see what's left. 6 goes into 12 2 times with an x squared left. 6 goes into 48 8 times with x squared y left. And 6 goes into 35 times with y squared left. What's left is not factorable, so the only thing that you could factor out in that particular case was that 6. Number 16, we have ax squared plus by squared minus ay squared minus bx squared. And the clue here is that we have 1, 2, 3, 4 terms. So that tells us to group. There is a negative in between. We make the correction when factoring just on that last term. You change its sign. The GCF of the first binomial, if you look at it, ax squared plus by squared, they don't have anything in common. So we need to do something different because I don't know if this is factorable or not. So I'm going to go back to what I had originally before I change this sign, and I'm going to do some rearranging. I'm going to put ax squared, and I'm going to put it with this term, minus ay squared, because see, they have something in common. And then my plus by squared, and this was a minus bx squared. So this one kind of has an extra twist to it. Now when I group them, I don't need to change that sign because it's a plus in the between, and I can factor out the common factor here of a, and I'm left with x squared minus y squared. Bring down your plus. Here I have a b, and I have y squared minus x squared, and we have another problem because these two don't match. So what do we do about that? That is a good question. I could try rearranging them a different way, but notice that this one is the same as this one except backwards in subtraction. So if I go back to what I factored out, rather than factoring out this, bringing this plus down, I'm going to factor out a negative b, which then means that what I have left is this. And now they do match. This is a really nasty little problem, just saying. If you understand this one, you can do factoring by grouping. This is not a very great example, but it's the one we were given. So what we have is x squared minus y squared times a minus b. And then the problem with that is this one isn't finished because it's the difference of two squares. So I have x plus y, x minus y times a minus b. And I think if you want a good factor by grouping example, you need to go back to the first set in this basic skills review and not use this one. This one is too hard. Okay, so don't worry so much about that one. We did get through it though. Number 17, we have x squared minus 8x minus 48. That is a trinomial, short process. So I'm just, because of the 1, I'm looking for factors of negative 48 that combine to make negative 8. Well, 48 has a lot of factors. There's 48 and 1, 24 and 2, 12 and 3. We've got 6 and 6. I've got 4 and 12, and I think this is where I can get my 8. I need a plus and a minus to get to a negative 48, but the bigger one has to be negative. So I believe those are my two factors. So that gives me x minus 12 times x plus 4. Whenever you're unsure, list all the factors. All right, a couple more we have before we finish up in this group. Number 18 is also a trinomial, 6k squared minus 19k plus 8, but it is a long process because there's no GCF and there's a 6 in the front. So we say 6 times positive 8, positive 48, and I want factors that add up to negative 19. So let's do those factors of 48 again, and then we'll figure out the signs. 48 times 1, divide by 2, multiply by 2, divide by 2, multiply by 2, divide by 2, multiply by 2, and I realized when I did it on the last page, we had an error. I had a 12 and a 3 and a 6 and a 6, so you can go back and look at number 17. We factored correctly, but somehow I got confused in here. Divide this by 2 is 12, multiply this by 2. I ended up putting a 3 there, so I hope some of you caught that in that number 17. In fact, I'm going to show you that again right now. It's right here. This is not, that doesn't make 48, and neither does this. I should have divided that by 2 to get 12, multiplied that by 2. And then when I divide this by 2 and multiply that by 2, those were my factors. So I hope some of you caught that. All right, we need a 19. Is there anything there that you see that makes a 19? Not so far, so let's keep going. If I divide this by 2, I end up with 4, so that would just be a repeat. So let's divide this one by 2, multiply this one by 2, and there is how I can get my 19. So sometimes it takes a while to come up with those pairs. Now let's talk about signs. I need to get a positive when I multiply. So I need a positive times a positive or a negative times a negative. But when I add them, I have to get negative. So they're both negative. Those were hard ones. These, because it's long process, are not my factors. This is the breakdown of my middle term. So I am going to bring down my first term. I'm going to break down my second term into these two pieces, minus 3k minus 16k. Bring down my last term. I now group. Notice that minus sign causes me to change the sign on my last term, and I'm now going to factor out the GCF. So 3k, 2k minus 1. Bring down your minus. My GCF here is 8, and I have 2k minus 1. They do match, so that is my first factor, and my second factor is right here, 3k minus 8. That was a little bit of a hard one because of coming up with the factors of 48 and because you probably had it in your head the wrong way from number 17. All right, let's look at number 19. This is a very simple one, and the reason is it's difference of two squares, meaning there's only two terms. it's subtraction, and they're both perfect squares. So you just go ahead and make your FOIL pieces, and you say, what got squared to make 81c squared? 9c, 9c. Make one a plus and one a minus. What got squared to make 4? 2. And you have it. Simple as that. Number 20 is v squared plus 12v plus 36. Although this is a special one, if you recognize it, great. If you don't, it doesn't matter because it's a short process trinomial. I just need factors of 36 positive that add up to positive 12, positive 6, and positive 6. Since it's a short process, I know it's v plus 6 times v plus 6, or v plus 6 squared. That's why it was special. It was something times itself. And finally, number 21 is a solve. 3 times 6x minus 7 minus 14 equals x minus 2 times 5x plus 4. Our steps for solving are get rid of fractions, distribute, combine like terms, get variables equal to numbers, and divide. So let's distribute because there are no fractions. So distribute that 3. This is just a neighborhood kid. Now be careful here. What is being distributed on this right-hand side is the negative 2. The x is like a neighborhood kid in the front yard. So negative 2 times 5x, negative 10x. Negative 2 times positive 4, negative 8. So we did that step. Now combine like terms on each side. So 18x, negative 21 minus 14 is negative 35. On this side, x minus 9x is negative 9x minus 8. We're now ready to get variables on one side and numbers on the other. So I'm going to add a 9x to both sides. I get 27x minus 35 equals negative 8. And now I got to get the numbers on the other side. So I'm going to add a 35 to both sides. Since the variables are on the left, numbers have to be on the right. And now, last step is to divide by the coefficient of x. And you end up with x equals 1.